Okay, so we are moving on with our operations of probability section of this chapter. We talked about last class, we talked about union versus intersection, what that all means, and then just using those ideas with a bunch of different ways to find data, whether it's given to you in a table or whether it's given to you in some way at like an equal probability, or like below here, it was listed out already with probabilities and finding operations between those probabilities. And so now we're going to learn a few more operations. And one of them is called conditional probability. And we're going to see it written like this, with this line down the middle. And what it means is it means the probability of a given B. So it's this idea of like, if we already know that B has happened, then we find the probability of that within, of A within B. How we find it is it is equal to the probability of A and B. So it's the probability of both of them occurring together, divided by just the probability of B. So that is how you find it. That is the formula. That is the operation with this probability. Okay, let's practice it. A public health department wants to study the smoking behavior of a high school student. They interviewed 768 students from grades 10 through 12 and asked them about their smoking habits. They categorized the students into the following two categories: smokers and non-smokers. The results are summarized in the table. A student is selected at random from the study. What is the probability that we select? And then we have a bunch of options. This is our relative frequency, right? Our relative probability. We've been given information and we're now making predictions based off of this data that we have gathered. A student is selected. We want to know what's the probability that we select a female. So we have this idea of the total amount, the total. So this is the total amount of students that were asked and studied. We've got smokers that were male, non-smokers that were male. We've got the total of males then here of smokers and non-smokers, which is just these two added together. Female smoker, female non-smoker, total over here of all of the females. The smokers here, we've got a smoker who's a male and a smoker who's a female, and then the total of all of the smokers is 314. We have non-smokers who are males and non-smokers who are females, and then here is the total right here of all of the non-smokers. So what's the probability if we just go in there and pick out random from these 768 students? What's the probability that we pick a female? Well, we go to the total of the females. We want the probability of a female divided by the total. Probability of a female is 354 divided, not the probability of a female. This is the probability of a female. And that is equal to the total of females divided by the total. Sorry, proper notation. You can leave it like that, or you can write it with 3 sig figs as a decimal. It should always be less than 1. What is the probability that we select a male smoker? So now, in order to find the probability of a male smoker, is the number of male smokers divided by the total. The number of male smokers is 169 divided by 768, which gives us a decimal of 0.220. Okay, a non-smoker. So now you say, okay, well, where are all of the non-smokers grouped together? Well, male and female non-smokers add up to a total of 454. So it's going to be 454 divided by just your regular total. Decimal of 0.591. Okay. So this is just your straightforward, this is not anything with conditional probability that we wrote up above. This is just straightforward probability. So this is something that you should be starting to feel a little bit more comfortable with. Hopefully these made sense. If these did not make sense, put a star next to it and say, okay, next time I'm in class with Ms. Connor, I'm going to be asking her questions about this. Okay. The next ones are your conditional probability. So your conditional probability is So a non-smoker, knowing we have selected a female, we can rewrite that as saying, what's the probability that we pick a non-smoker given that it is a female? Right? So given the fact that we know that this person is a female, what is the probability that they are a non-smoker? The idea of conditional probability is you've shifted what your total is. You've shifted from the grand total of all of the people added together. You're saying, hey, I know I'm picking from a pool of just females now. So now your total turns into the total of females, okay? So we can think about it as a formula. I do believe this formula is in your formula packet. The probability that they are a non-smoker, so I'll do S prime, signifying a non-smoker, given that they are female, is the probability that they are a non-smoker and a female divided by the probability of a female. And if you think about this conditional probability formula makes a lot of sense. You've changed your total to be divided by the total that you're looking at, which is now you're just kind of zoning in on a certain part of the data. So you're zoning in on just females. So your total now has become just the probability of females. And the probability of a non-smoker and female, you're saying, okay, out of all of these females, which of them are non-smokers? They're both a female and non-smokers, which is what this up here means, the and. Okay, female and non-smoker is a total of 209. And then the total of all of your females, follow that female column or that female row all the way across. You'll see that it adds up to a total of 354. So those are your numbers that you pull out from the table above. You can write it as a decimal, which is 0.590. All right, we'll try another one. A female, what's the probability that we pick a female given we've selected a non-smoker? So again, this is this idea of shifting focus. We're now zoning in on the fact that we are now only looking at non-smokers. What's the probability that if we're just looking at non-smokers that we're going to pick a female? So the probability that it's a female given that it's a non-smoker. Very similar, obviously, to our last one. It's almost like I planned it. So these guys are very, very similar, but you're going to notice that it's going to be different. So the probability that they're a female and a non-smoker, which is equal to the probability that they're a non-smoker and a female. But now we're going to divide by the probability of a non-smoker. So this number is still the same. If you're a female and a non-smoker, that's still out of 209. The non-smoker total is 454. So you follow the non-smoker column all the way to the bottom till you see that total. So now we're dividing 209 by 454, which is 0.460. So let's break down what this means. This, a non-smoker, given that it is female, if we're just looking at all of the females, if we gather all of the females into a room, we have smokers and non-smokers. And if you split them up into smokers and non-smokers, this is saying of all of the females that we're looking at, the non-smokers make up 59% of all of the females, which means that a very small but still valid majority of the females that you're looking at are non-smokers. So most of the females are not smokers. Versus over here, you're taking all of the non-smokers and putting them in a room. Male, female, doesn't matter, you're putting them into a room. And then you're looking at all of the non-smokers and say, okay, split up males versus females. Which of you are male and which of you are female? And here it says, well, of all of the non-smokers, 46% of them are female. So when you're splitting up a room of non-smokers, slightly less are non-smokers, right? So mostly the males are non-smokers in that room. So it's a different shift of focus.